Nozzle heats up and the plastic it flows. A creation takes form as the live stream goes. Heart of a maker with a tech-savvy show. Designs in the making, see the hotbed aglow. It's shenanigans 3D on the digital stage. With each layer printed, he's the maker, the mage. Spinning gears, let's start the show. Layer by layer, we watch it grow. A twitch in time with shenanigans flow. Chaos reigns with a fiery glow. Closely as the filament spins, a wild ride where the line between fails and wins. Accidental art when the plastic rebels. Shenanigans 3D, he's breaking all the levels on the edge of tech, where the sparks may fly. In the streamer's den, there's no limit to the sky. Every stream's a gamble, roll the fiery dice, pushing limits, bending rules, not one to think twice. Heartbeat pulses with each bridge he creates, while the chat's wild wonder in suspense they wait. Rising with the flames in the shenanigans game, printing out the future, no two prints the same.
I'm here. How's everybody doing today? Cruising Girl, welcome, man. You beat this. Started the stream, huh? Phantom, how are you, my friend? I had to shut Lumia's stream down. So, I don't... Well, it might be actually still on. No, it's all shut down. I started having issues again with my dropped frames there. I don't know what the hell's going on here. So, unfortunately, we had to shut it down. I'll sit there and reset everything after the stream and see what's going on. This usually happens when my son, right after my son plays his video games on my PC. I don't really allow him to do that, but from time to time I let him, because I keep telling him, no, this PC's for, no, I call it, it's my work PC, right? Anyway, we still really need to get that PC up and running for him. Welcome in robots. All right, so check this out. I was thinking about some things. We started making that tank, and I was like, well, you know what? What if we use a Raspberry Pi for the heart of the system? And then I started looking into Raspberry Pis. I have one. I got one right here. I got a Raspberry Pi 3B, and as you can see, this thing is so old and it's been used and everything else. And while I was doing research on the new Raspberry Pi 5, because I'm thinking about getting a Raspberry Pi 5. I can get one for about 60 bucks. I tagged you in a post on Maker's Discord. Okay, I'll check that out. Should we check that out now, or should we wait? They have AI. They have an AI hat for the Raspberry Pi 5. I think you can use it for 4 and 3 as well. You wore out a brass nozzle printing glow-in-the-dark filament. So yeah, so we're gonna take this track machine, and I got an idea. I think what we should do is we should build a shenanigans tank. We can't put any kind of flamethrower or anything like that on there, but we should build it where it's a platform where you can change out things. So we'll have it like, yeah, we'll build it like a platform. We'll have the tanks. We'll run a Raspberry Pi through it. We'll run the AI on it, and we're going to run LiDAR. Yeah, we're going to run the LiDAR on it. We're going to get one of those revolving things. They're actually pretty inexpensive. I found one for 50 bucks. but we'll put it on top and it'll spin around. And I'm thinking about running a AI camera on it, and we'll see if we can just get the thing to do whatever the hell, like go about on its own, right? Why not? But we'll build the tracks, everything as a platform where we can interchange the front of it out. We can put like a robot arm on it or whatever. About 3 printed neutron rockets using carbon fiber. Ooh. Let's see if I can bring Lumia stream. I'm getting full. All right, so let's see if I can reopen Lumia stream. I'll have to read that. I'm a little torn. I'm a little torn on what I should do for the drives. If I should use a DC motor.
Opened.
Or if I should use actual rockets. It's in Tribelands. If it's what I think it is. RPIs limit their power voltage to 5 volt. Well, would that make a difference? Would that make a difference if we're using an H bridge? Basically, I'm just using the pi as the heart or brain, I guess. Then we're going to do serial from the pi into an Arduino. And then with the Arduino, we'll have the H bridge. The Arduino will will be the heart of the system for all the motors and for the steppers and stuff. The pi is going to run the LiDAR and the AI. Yeah, look at the size of that thing. What did it say, 90 ton? A 90 ton 3D printer beast. Oh, they plan to launch the first neutron rocket next year, in 2025. Oh, is there any other? I was hoping they have pictures. Look at that thing. That thing is massive. That's all carbon fiber. Wonder if it's continuous, like, right? Wonder if it's that continuous, or if it's just regular carbon fiber, like what? That's wild, man. That's crazy. That's crazy cool. I'll have to do some more looking into that. Maybe we should start printing all of our stuff and like all our rocket stuff in carbon fiber. I got some carbon fiber nylon. We should start printing it in that. Yeah, maybe it'll last a little bit longer. Used to have a carbon fiber bicycle. So Cruising Girl, if we run the Pi, if we take the Pi and run the AI camera and the sensors on the Pi, and using the Pi to send serial to an Arduino, where the Arduino will Arduino, whatever it is, use that to control all the motors and stuff off of an H bridge. Would that be a better route? Because that's what I was thinking of doing. I wasn't going to power all the steppers and all that stuff off of the Raspberry Pi. The Raspberry Pi was just going to handle all the sensors and basically tell. Yeah, that's basically all I was going to think about doing. But I found a cool. It's called ROS, I think it is. The power bus on the Pi. Huh. We'll have to look into that. I have to look into that. Yes, carbon fiber would burn better. It would probably burn a heck of a lot better. Yeah, we'll just have a bunch of fire. Craziness, fire, and stuff like that, right? Excuse me, pardon me. Okay, so we are now like full-blown running the way we should be. I wonder what was causing that issue. I wonder if it's my WLEDs causing the issue, because I remember when I was running addressable LEDs over the network for my Christmas lights, I had to do a completely separate network for those because they're just bogging down my system. And so we're going to test that out right now and see if we can get there. We're going to allow those to bang nuke. Yeah, I don't think anything. That should work, huh? Camera's on this. Sorry for being late, by the way. I ran into an old friend. All right, our numbers are good. We are well above. Hell, I can run freaking. I can run full. I can run full everything if I wanted to, but that I'd have to shut my stream down to reset that. But yeah, we're good. We're good on numbers today. I don't know what the heck. It wasn't good. If you notice, I stopped the stream. I started the stream for like 30 seconds and I stopped it and I shut everything down and I restarted it again. But yeah, we're all good. Okay. Work offline. So we'll decide on what to do with the heart of this, with the heart of the system. Maybe I'll reach out and pick your brain there, Cruising Girl, and see what you think we should do. But here the bottom line. This is going to be something constructive for all of us. Like I want everybody to contribute to this. Because this is something that we're going to be taking to Murph. We'll be taking to events. It'll be on the table, right? So what I want is a tracked mobile. A tank, right? With the front plate to be interchangeable. You can take a plate off that has a robot arm on it, or you can put down a plate that doesn't have anything on it, or you can put down whatever, So you can take the front plate, and the things could be probably about maybe that big, I guess. I don't know, or somewhere around there. We'll keep it within like a 300 millimeter build plate or something like that. I don't know. It might get bigger actually, but something you can definitely. It might print the body on the build plate twice. But anyway. It's a channel, not a bang redeem. But it's going to be a tracked machine. We are going to run RP LiDAR, the 360-degree LiDAR system that spins around it, you see. We're going to be using that. We're going to be using, it needs to have a camera so we can, view it. Has to be remote controlled. Build a robot, welcome in, my friend. And thank you for the lurk. It's probably busy for you. It's a Monday. Yes, it's going to be a modular assembly. I was actually thinking about this. We're going to start off using this NEMA 17. But the more and more I think about it, I think I want to switch it out to one of those right angle motors, the beefy ones. So we'll make that modular as well, so we can just swap them out. Yeah, that's where there are going to be some extra parts on this, but that's the idea. That's what I want. I think the baseline is we get the machine some way built. I'm hoping to start printing it here this week, and then we can decide on. We'll have to. What we should do actually is, for our mounting system for all this stuff, now it's going to be internally cooled. We're going to have fans on it and everything else. But for our mounting system, because here's the Pi and here's a hat for the Uno, what we'll do, since all these the holes don't line up, we'll have a stationary, or we'll have a universal mount. Okay, for like on the machine itself, we'll have a universal mount. We'll just have like 4 screws or whatever, and then you can print 3D print adapters for whatever you go with. I think that's what we can do, right? So we'll just have like 4 screws for the base, and then we can for the holes here, we can just kind of make an adapter. Oh. There's a cheaper tool changer. They're using a posted magnet thing to hold them. Yeah, I don't know how well I trust that. If there's any tool changer I'd really trust, it would be the black box. To see how that works in person, how their system comes in and locks in person. That thing is precise. No wonder the darn thing's so expensive. Yeah, is that the reason why the Pi corrupts the storage? So yeah, I've had problems where like everything, my Pi is like gone wacko. That's how you end up being in a channel before you start. Yeah. I started it up, and then like 30 seconds later I shut it down, and we're all running good now. So watch it. Yeah, if you have the link, go ahead and share it. Are we allowed to? Yeah, the black box is awesome. I was really, when he first came out with that last year, I was really when I first saw it last year, I was really paying attention to the mechanism, because I told him, I was like, the only thing I'm worried about is having that offset. No. Having the machine come down there and grab up another tool, and having that tool be offset. And he's like, no. And then he opened it up and showed me, these pins in here, and they go in, and then there's like this round ball thing that goes in and twists and lock in place. Yeah, that thing is solid. Okay, so let's open up. Please, God, tell me I saved it this time. Oh, I did. I called it Death Tank. So this is what I have so far. Put in useful links. Cool. Well, let's look at it. I have Discord open, so this look at it real quick. What? Father and oh, that's what the chime was earlier today. I heard a chime at some of my Discord. Engineers grow. Time to break free from expensive tool changes for 3D printed. Okay, give me some. Oh, I see. Huh. Join the tool charger membership waitlist. So he's basically 3D printing one. That's the coolest thing ever. Okay. Yeah, I'll definitely check that out. So we're gonna start here. This is what I got so far. Let's get to I was working on this. We started working on this last night. I apologize for the stream last night. Me just saying to hell with it and giving and just shutting it down. But I was saying it on stream. I don't know if y'all heard it last night or not. I just cannot put content out like that. If it's all choppy and breaking and I can't do that. It's an OCD thing of mine. Plus, I don't want you guys to go through that. Suffer through all that choppiness and it's just not good content as far as I'm concerned. So that's why I just end up shutting the stream down. So there's two variants I want to do here. This will be for the stepper. I don't know if we should use steppers or not. I'm questioning if we should use steppers for the drive system. Like, what's the point of the stepper? The point of the stepper is to be precision, right? To be precise, to precisely control something, a motion, right? You really can't do that with DCs unless you have some kind of a reader on it. So using a stepper for our application here, is that like extremely overkill? What benefit do we have with this? Of using a stepper for the drivetrain? That's basically what we got to figure out. We could use, let's see if I can, see this is, I really wish my homepage wasn't full of celebrities. Junk. Let's try, let's see here, 93. Oh, I don't want to take that whole thing. Pardon me. So what if we use something like these? Volt, 16 RPM DC warm gear motor, high torque turbine electric gearbox motor, self-locking reverse mini engine geared motor for DIY robotic door lock curtain machines. Okay. If we use something like this, we wouldn't even need to. That's 8 millimeters. We wouldn't even need to do the the pulley system inside it, that thing would be probably like super torquey. I definitely want high torque. So if we do something like that, that's $26 a pop. And we can definitely run one of these off of that's only 1 almost, it's just less than 2 amps. Reduced gear ratio. That's a hell of a lot torqueier than this guy right here. My God. You can cruise and grill. You actually can. I thought about doing that myself. I thought about using just one stepper or one. You'd have it's almost like a limited slip kind of transmission kind of thing, differential. Similar to it, and what you can I don't know what it's called. I've come across them before. It's been a while since I've looked into them, but I've come across them before. And it's the way the transmission works. It's like a clutch transfer case with brakes on it. It's been a while since I've seen one, but I'm just kind of pulling one out from trying to remember it from memory. But what it is you use a servo or braking or whatever, and you will brake one axle. So you'll apply pressure to one axle, and it'll slow it down, and then it will act like a differential, like a normal differential, where it'll apply power all the way to the other side, and that's what will spin your thing. But it's been a while. It's definitely been a minute since I've looked into it. I wouldn't even know what it's called. I'd have to do some digging to find it again. But we definitely would want 2 motors. The only problem with DC motors like this is they're not identical. You're gonna have one that spins up faster than the other. That's probably hydrostatic. Yeah, most likely the cruiser grill, that's hydrostatic. And that's easy to do. You just control the flow of the fluid. You know, we can. So this is going to be operated off of pulse width PWM, right? So if we do find one motor's a little bit faster than the other or slower than the other, we can tune that out with the PID tuning. So, do you think we should go this route? I think we probably should. Are there any others? Other cheaper ones. Oh, what are these guys? There is one with two shafts, yeah. But then then the only reason why I'm not going that route, why I decide against that, is that would be more complex. We'd have to have a transmission and stuff in there, and I don't really want to go complex like that. Look at this. Here's we got 120 RPM, high torque. Cruiser Girl, thank you for being my mod. Pretty awesome at it. This looks like this person using this for how torquey are these things? These are only 12 pieces, or yeah, 12 pieces. That'd be nice if it was 12 pieces, right? You get 12 pieces for less than 20 bucks. So here's 35 RPMs. We can do what, run 65 RPMs? Probably. Lumia, well, Lumia is always out of sync. Everything in my channel is always out of sync. Oh, I did hurt myself there. Did whack it. Okay, so let's see. I know I want to get. I don't care about packaging. I want to see what we could use. One of these, two of these. I want to know what that shaft size is. I want a description, please. There is no descriptions. So we can get two of these for 20 bucks. It's not bad. 3D Print World 1, welcome in, my friend. And then, okay, so here we go. Frequently bought together. 6mm rigid flanges. So this has a 6mm shaft. Oh, it's right there, 6mm shaft. I'm running 8, but I can drop everything down to 6 actually. I'd have to replace my bearings. That's the only issue. We could do this. Doesn't say, it's not giving me, we have. what's the overall length is 78, so that's close, and we can actually run this direct. You know that we can actually run this. We can actually run this direct. I'm doing good, my friend. How are you doing today? The stream is back up and running, and it seems to be healthy right now. So apologize again for last night's stream, but yeah. We could go this route. How about it? What do you say? Do you want to go this route? I would really like to know what the specs of this are, though. Let's watch a video. These are actually used quite often. Ooh, comes in a nice box that's a discreet box for your protection. What's the model of this? That really wasn't too. Let's see if we can find a. Let's see here. I watched. GrabCAD. Let's see if we can find this in here. I watched something in I'm not gonna say who and all that stuff, but I watched a video of somebody saying about they did some how it's bad to share and you share 3D printed files if you buy, like, you know, let's say you bought a model from Build-A-Robot and then you share that file to others, how bad that is, right? But that same person turned around and said that they did it. So it's like, model code. Oh, you talking about a bunch of singing steppers. Yeah, there's a bunch of people have done that. There was a G code command that you could, I don't know if it's still, I'm sure you can probably find it somewhere, but there was a G code that you can add to the end of your Ender 3 where, was it before or after you modified the code, or you added it to the end of it or beginning of it, but where it would play the Mario theme song when your print was done. We'd have to find that. "90-degree motor." Why doesn't this never there? Okay, so there's that one. Here we go. So there's that. That looks like that might be it. but unfortunately I can't use that file. SolidWorks rendering. D-shaped output shaft size, 614 millimeters. It's saying that this shaft is 614 millimeters in diameter. That's not right. Gearbox size is 37 by 24. Well, I can't really. As an Amazon associate, I earn from qualifying purchases. Oh, here's a link to it. Oh. That's 6 millimeters. So this is it, actually. What we were just looking at. Okay, cool. So we can model this. We can use this as off our model, and then we have that link. Let's do a. Am I signed into this? Yes, I am. Custom Mario screen song. Glendon, how are you doing, my friend? I was thinking about you the other day. I think I want to get myself one of those keyboards and put together a keyboard. I was like, I gotta reach out to him and see what I need to do, because I've never done anything like that before. It needs to be cheap. Christmas is coming. My boy's getting more expensive every year. Yeah, it does look like fun. I would like to do one. Okay, so let's get our step file. Oops. Ooh, darn it. Get back. Alright, so this person has the dimensions of this motor. Look at that. That's awesome. So let's download all the files. Cool. That's awesome. Mostly open wallet, yeah. He tried to convince me into buying him this Halloween knife thing. I was like, no, dude, I'm not buying you that. Tell your mom to buy it for you. You just spend all that money on Saturday's trip. It's a cool little thing. I might end up getting it for him anyway, but I know his mother's not gonna get it for him. But I'll probably end up getting it for him. I'll probably stop tomorrow and get it. It's a prop. It's a knife, right? He's going to be a zombie this year, and he found a knife at the box store that it has liquid inside, right? So it's a knife, but then it has like a clear sheath over it, and it's like red blood looking stuff, so you can move it around and switch it around and stuff. All right, so we downloaded that. So let's take this and get into, close this out, and we'll get into this. We need to, let's go to the big screen. We're gonna need to change things, aren't we? This whole design completely went Wayo. So we're gonna start a new design, I guess. Yeah, I tell you what, I don't know if it's you don't even want to know how much I spent on this train layout a few years ago. That was ridiculous. I mean, no, I didn't hold back. It wasn't some kind of toy thing. It was a full-blown model train layout, right? Hobby level, right? It's all on my YouTube channel. There's several videos of me putting it together. And I tell you what, those things were I had one of his trains laying right here. Those trains are not cheap. Those locomotives, they're like $200+ for one of those little locomotives, and he got what, 2 of those, and the track for the trains, I think I probably had maybe $150 worth of just track, and it's just a simple train crash channel. No, we will be, that's all going to be on. We were down there getting things all figured out, where to put everything down there the other day. So that's coming soon. That will be after Christmas. That will be 2025 when we start doing the build downstairs. Most of that stuff, most of those rolling stock and everything is all going to be 3D printed. We're going to downloads. It's crazy. I would say an easy $600 went into that layout. Yeah. I slowed when it snows out. I slow down. I slow down. I don't like driving in the winter. Plus, if it starts snowing here, they shut the roads down for all commercial vehicles. They've been doing that a lot lately. They just now, over the summer, so there's a couple mountains that we go up that I use regularly. They now installed chain areas with blinking lights and everything else, that if these lights are blinking, you have to stop, pull over, and you have to have chains or you can't proceed. Yeah, well, most of our editions and all that stuff is all going to be 3D printed. So that's the cool thing about it. Pretty much shut down in January. Yeah. Okay, this file, let's export this. All right. Why does this look different? This up here looks different. I had like 3 or 4 things in here. Something changed right here. There were like 2 other things in here. They just didn't update. Who knows? Okay, let's insert. Yeah, they still 10 fields here, but you know, I'm all here in dairy, so no, I'm in dairy land. Minute Maid lemonade. How in God's yeah. Okay, I think this motor is, this shaft looks like it's centered. So we got one centered here. Let's move. Do 300 in sales a week in January. Yeah, that's oh, God. I don't know how you'd live off of that. Definitely have to save throughout the year for that, huh? Oh, we're centered. Yes, we are centered. Let's do our. Let's go for the top view. That's our right, that's front. So if that's front, this needs to be changed here to 90 degrees. Wait a minute here, I'm getting confused here. Because we're not using belts now, so this needs to be like that. It needs to rotate it this way. Yeah, I do the same thing too. I prepare for downtime, which is what I'm doing. Like, what I've been doing here these past few months. This last month, I've been preparing. Usually October, November, and December, I start preparing. That's why I keep saying budget's a little tight right now. All right, what am I doing that I'm confusing myself here? Oh, this needs to be this way. That's what it is. Crops didn't do well for you. Humbler John, my friend, how are you? How was your weekend? Yeah, unfortunately, we didn't make it down that way. Okay, so there, we're good on that. Let's move this over. Let's move this 40. Oh, Rexy, hey, how you doing? Still 3.5 hours away from Atlanta. Well, have a safe trip. I hope it was a blast for y'all. We are redesigning this is the third design now that we've done for the for our tank, but this is a community effort of parts and electronics. And this is what we're going to be taking around to shows for 2025. It is an absolute blast. Awesome. Awesome. That Ren Fair, behind the Ren Fair, there is a facility behind the Ren Fair, and it's one of my customers I go to. That is awesome. Glad y'all had a good time. Okay, we're going to insert, we're okay with that when we said 40, so we're going to add another one. I think this is a better approach. So if we go this way. And then we turn it 180 degrees. And what did we say? We did 40, right? Yeah, we did 40. Yeah, I kept getting text messages from their Discord saying that people need rides. Someone needed a ride to Philly to catch a Greyhound, and it's like, yeah. Oh, I've been there, done that. This is going to be interesting to figure out how to mount this. I guess we have screws here. So what's our distance overall from shaft to shaft? 121 millimeters. Let's get a spring up grab cat again. And this, download the Raspberry Pi model. This will work. I don't need anything fancy. I just need it to. Printopia is your goal for next year, huh? I'm gonna have a table next in Printopia. That's the idea. It's a plan. Share a table with Billiverbot. There's talk about that, so we'll see what happens. I would definitely do that. To Raspberry Pi 3, and this is one of the reasons why I want to get this done, so we can take this there. Open this file up. Welcome, Sam. Welcome in. Thank you for the sub. 8 months in a row. Thank you for that. How are you doing today? Hope you're having a beautiful Monday. Yo, 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 yo. Did I say, how many times did you say it? 5? Well, I said it 5 too. We're building a tanked robot machine thing with AI. We're going to be using AI for, I don't know what for. I found this cool thing where take a Raspberry Pi 5, they have a hat for it that has AI on it with a camera. And my idea is to use that to do missions and stuff like that with. That's the idea. If it's going to work, I have absolutely no idea. That's the idea, though. Exactly, Mighty Bean. That's how we just destroy the world. Humanity's going to end that way. How are you doing, Mighty Beans? Welcome in. How much is a Raspberry Pi 5? I was looking them up, and I was finding them for around 60 bucks. 60 bucks for the Pi 5, and then for the AI hat was around $60. Here, let's look it up. If you go through, if you do it all through Raspberry, the Raspberry site, whatever it is, if you go through Amazon, you're paying like $100 for it. Yeah, if you... Where was I seeing that at? Here's $80 for one. DigiKey has them for 60 bucks right here for the for the 4G. Yeah, 4G, the 4 gigabyte ones. $60 for the 4 gigabyte ones. That's the one that we're looking at, that I was thinking about getting. The other thing I want to search is yeah, this does not look like what I was looking at before, but maybe this is just the bottom model, I don't know. But here's 28 bucks for this Seeds powerful RIS V-based hat enabled AI in Raspberry Pi, and it's ideal for AI vision projects. So I want the machine to be able to spot something. We're going to run LiDAR. We're going to run that 360 LiDAR on the top of it, plus an AI camera. And I think that should be good on sensors. I'd like to see it try to like have it avoid obstacles. And I want it to, with an arm, I want it to try to reach down and pick something up. The arm is not going to pivot. The arm is basically going to have 1, 2, 3. It'll have 3 joints on it, not counting the open and close. So it's just going to basically unfold, fold down. We can move the thing around and then pick something, like the claws will close, pick something up. So yeah, we're only going to have like 3 joints on it. That's eventually. That's where we're going to be heading, Bill Everbot. I thought about building a death racer. I'm going to reach out to BTT and see if they'll sponsor a death racer for us. We'll put sensors on the side, like avoidance sensors, that if somebody is coming at us, it will. Oh, what are those wheels called? Oh man, they start with an M. Manley's wheel. What are those wheels called where you can? I know they start with an M. Where they have rollers on them. They have those like 45-degree rollers on them. Yes, we'll put those on a death racer. So if it detects, we'll put LiDAR on it or something like that. Real simple LiDAR, right? Or if we detect something coming at it at a certain velocity, whatever, it will go in the opposite direction. Wouldn't that freak everybody out? Everybody like, what the hell? Yeah, so that's the idea. Right now, what we're going to do with the platform, we download this, right? Yeah, I think we did. Yeah, it is. It's ready to be exported. Right now, it's designing the platform. The platform in the back is we're going to have it to where you can swap out whatever component you want for it. We'll have a base plate for the Raspberry Pi, or we'll just have a simple base plate, and then you can get it. You can print adapters. So if you want, use the Raspberry Pi or Arduino or whatever microcontroller you want to use, there'll be you can do an adapter for it. That way we can keep it universal, right? So let's export this and let's start working on. I'm gonna base everything off the Pi 5 because that's what I'm leaning towards right now. TechJeeper, my friend, how are you doing? So this is the third innovation. This is the third version of this tracked robot machine that we're going to be building. But now we're adding AI to it and a rotating LiDAR system to it. You know, I thought those LiDARs were going to be very expensive. I found one for $50. I mean, that's still quite a nice chunk of change. You know, that's 2 rolls of filament, possibly 3. But yeah, I thought they were gonna be like $200 or $300 for it. Just 5 years ago, they were like $100K. I know, right? There was one, I found one on Amazon. I don't know how good it is. I do have I use LiDAR. I've used it before. I got some on my quadcopter actually. So I've played around with it and it does work. Oh, so here's a LiDAR module. And it does work. I can hug the ground when I have this turned on. When I'm running an autonomous, and I have this on, it'll sit there and it will actually follow. There's like a slight delay, but it will follow the terrain. It'll go up. My fields over here. It'll go up and follow the contour of the fields. Oh, my cat is in here. Hi, kitty cat. Do a collab on a death racer? I'm gonna reach out to TechJeeper said about reaching out, so I'm gonna try to reach out and we'll see if we can. Yeah, I'd be interested. Okay. So we're back to square one of building this. Oh yeah, that's what I want to do. I want to import. I like if those motors are to scale, that ooh. I wonder how much torque those motors have. A sculpt body for it. Oh, really? That'd be pretty sweet. Yeah, because I thought about making a death racer where a person's riding a jet engine. Having basically the body the shape of a jet engine with a front propeller that spins. But now I'm envisioning. I'm seeing a. Why can't I say that word today? A rainbow-colored unicorn. Or while you're whales. Or no, well, there's something. Oh, the bear or something. have some serious fun with it. Okay, so let's do this. I know, that's what I was thinking, Tech Cheaper. Having a flexi on it. That would be sick. Having a flexi body. Oh, crap. We need to center this. Okay, there we go. I know. I have a flexi on it. Dude, that would be sick. I guess we could have the motors mounted on the bottom. We can raise this up. We have a mount up here. The motor, see, this is one thing that if you gotta think ahead when you do these designs. Now, I'm not an expert at this by far. Just a truck driver that comes home and plays on the computer and streams it. So, I mean, and prints it. So, but you definitely gotta think ahead here. Because I mean, if we put something here to mount this, and like this is the bottom, right, and this is the sides, we can't just put something like an object like right here in this area to hold this up, right? We would have to make sure that we have it small, because we'd have to allow these motors to move out this way and then back, because that's going to be underneath that motor's going to be underneath all that. We're not going to be able to pull these motors straight up because the shaft is going to go through the body right here. So when we unscrew this motor needs to be moved inwards and then removed out like this. So you got to think ahead of like that. I was watching this one YouTube guy maybe a year or so ago, where he did that exact same thing, but it's a different style of motor. But anyway, what he did is he designed everything, put it together, 3D printed the body, and then he couldn't get the parts in place because he didn't allow to what I was just describing. He wasn't allowing for that, so he just designed it. And then he had to completely redesign the whole thing, and he showed it too. He said, and I was like, I messed up, and he showed it what he did. Yes. I think we did. Why did we move away? We didn't really fully move away, I don't think. Maybe we did. Why did we start designing this? Oh, we were talking about the advantages of the stepper. What is our? I know it's a Monday. All right, it's just a Monday. I haven't had much coffee. It's just, I'm still half asleep. What is the advantage that we have with a stepper as the drivetrain? Besides of me already having them, what would we benefit from it? It would be precise. What would we benefit from it, though? Oh yeah, definitely highly accurate. We'd be able to park this thing. We'd be able to park it anywhere. One thing I do see being beneficial if we use this with the robotic arm, since the robotic arm does not pivot. All right, so the robotic arm does not pivot at all. All it does is it folds up. Basically think of your shoulder as being precision control. Precision control is what this would, we would do this with precision. So the robotic arm is basically going to have two arms on it. All right, so it'll move up. We'll have the boom that goes like this. Then we'll have the boom that goes like that. And then we'll have the grabber. But the grabber will be able to go up and down like that. It'll be sideways, pinched like that, but we'll be able to go up and down like that. And in order to move that robotic arm to like pick up a can that's over here, we'd actually have to turn the entire body of the machine, because it's not going to pivot, right? So the arm's not going to pivot. So the entire body needs to turn, which that's where we can get, the steppers would come in awesome for that, right? We'd be able to precisely move that. If we go this route, we would lose that precision. And then our motor shield, one of the motor shields I was looking at, one of the H bridges. The H bridges I've been finding will control 4 steppers and 2 DC motors. That bridge will work on this model right here that we have in front of us, because we have, for our arm, the arm will have 1, 2, 3, and the pincher 4. The arm will have 4 steppers on it and 2 DC motors. If we go with these motors right here that we're working on. Yeah, we're not going to be doing, these are NEMA 17s right here. They're 41, or they're like 40, what is it, 41 or 42 by 40. These are 40. We can get, with this warm gear set up with a DC motor, we can get high torque out of this. I'm not worried about speed. I'm not worried about speed at all. These motors will produce high torque. These 90-degree warm gears. Well, they will probably out torque this, won't they? They're going to be driving it. You only need so much torque, exactly. But how much torque do we need? That's the question. How much torque do we need? Now, the thing about this though is, if we go back to that other design, if we go back to the Death Tank design, this one right here, okay, the one that we started with. Oh no, this is the second version. Where is the other version? I'll show you the first version we started with. So this is version number 2. Here. So this is the first one. And I was going to use these little guys. But then I know for a fact that these are not torquey at all. Because no, I can stop them with my, just easily stop them. Yeah, more torque means more weight. Yeah, that's just like, yeah, it's just like bigger battery equals more flight time, but it also adds more weight, which reduces your flight time on anything like quadcopters or anything like that. So yeah, this was the very first one that we started, And then I started thinking about it. It's like, no, I don't really like using those. And those are the batteries. But yeah, I don't really want to go this route. So then started working on this. This is with the steppers. Now, the steppers are going to be reduced. So we do have a reduction here. And actually that's, and then this one, which we haven't even, we just started this today, uses that. Should we go with the stepper motors? What do y'all think? All right, let me. How do I do this? I guess I have to go to my channel, don't I? almost put it on sub-only chat. Well, I don't see how you do it. That's it. Yes, let's create a new poll. Question. What should we use to drive the tank thing? Should we use a stepper? Oh, that's not how you spell it. Forgot the T. Or a DC motor. We will do a 10-minute poll. We'll start the poll. There we go. Your vote is pasta and a rocket engine. Well, yeah, well, that sounds about right for our channel, huh? So we have a current poll, DC or a stepper? We'll let that run and we'll check it out. We'll see what y'all say. But I think what we should do right now is something that's bugging me. I wanted to put a belt on here and we will do a belt. Let's do... construction plane. So these belts are 6. So that's 60.6. So that should be 67. Oh, that's not okay. So, pardon me. 61. Okay, we'll start here at 61. We should do the belts. Let's get rid of all these bodies so we're not. Got that pulley and that pulley. Okay. we'll design the belt. That's good enough. I'm not really sure how to do this, to be honest with you. So I think I want to run a parallel line from here to here. We're just gonna fudge it. We're just gonna eyeball it. That's all we're gonna do. I'm not really too concerned how it looks. I just want it to be in there for aesthetic reasons, I guess. So we'll do that down there. That was supposed to be, let's backtrack on that. And this is this. We could do the math to do it and make it look right, but yeah, see, this needs to be moved up. Well, that looks good, huh? So now we'll do the bottom one. That one looks about right. That works, huh? That works. So now let's take this and we will flip it. Right, okay. Finish the sketch. make this at 6 millimeters because I think they're 6 millimeters. Hit OK. Yeah, that was easier than said than done. That will work for our demonstration purposes. We need to make it black though. Rubber. Now, we're going to take and mirror this. And now let's bring everything in. Cool. That was actually quite easy to. That's actually quite easy to do. So now we do have. So doing this will actually make these steppers torquier. I just don't want this thing. No, so I want this thing to be able to go outside. All right, it's not going to be an indoor thing. It's going to be full blown outside, going up through grass and bushes and brush and everything else. So that's why I want to make sure we have torque on it. I don't want it to go up a hill and stall. Yeah. Okay, so now let's try to figure out how to this is all the inside guts. We need to bring we need to figure out how big this our sprocket's going to be. Oh darn. Tell you what, I'm going to take a stepper, 100% on the stepper. View our results. And we got 100% on the stepper. Okay. We'll end the pull. Could not end pull. What? Delete pull. All right, so we're doing this. We're going to do the steppers. Cool. Not to buy anymore. We have the steppers to do it. We can keep the budget down. Okay, so now I'm gonna take a quick break. I'll be right back. Come on, doggos. You need to go outside. Here, make it quick. Stop. Okay, yeah, we're back. What? Yeah, oh, we need to find out for the battery size so we can get this. Oh my God. You know what my mail does? Every time I come home, every single time I come home, he has to greet me a certain way. If he doesn't, he will not leave me alone. He will, like, literally try to knock me over. He has to jump up and put his paws on, like, on my arm, and he'll reach over and he'll give me a lick on the inside my head. Just one lick. And then he jumps down and then he goes out. He will not go outside. He will not do anything. He will stand and bug me until that's done. Once he does that one time, then that's it. He's off doing whatever. It's routine every single time. We need to bring in our batteries. There is a way that we can import this. We got to export that and import that. So let's cancel that. We'll go back to our tank. From here to here is what? Okay. That's not gonna work. I'm not. Let's save this. We'll save this as tank bot DC. Oh, our batteries. That's what we're trying to figure out. We're trying to figure out our batteries. What is the overall distance of it? Let's do the top view of this. And I want to get, we can print this on the bamboo, or not the bamboo, print this on the K1. So we can do 300 by 300. That'll give us an idea of how this is going to big this is going to be. So this is the back of it. So we can move that back more. We have more room up here. This is 100 millimeters from here. Well, it's not 100 millimeters. It's 100 millimeters, but it's offset. It's angled. So from the center point here to the center of this axle, that's 100 millimeter. That is a 300 millimeter belt. The belt does have to have a tensioner here. So the belt's actually going to come around, wrap around like this, and then come up to get rid of the slack. And there is going to be slack in that belt. I found a cool online calculator that calculates your belt length. All you do is you type in your diameter of your pulleys and the distance between the pulleys and the center of the axles, and then it will calculate the size of belt you need. And this one, for 100 millimeters, a 300 millimeter belt will work, but there's going to be some slack, and we're going to put a tensioner in here so we can bring it down. But I really don't want to. I really don't want to print bigger than a 300 millimeter build plate. I want to keep the body within a 300 millimeter build plate. So I want the body to be printed as one. And I think this would work if we have. What do we have from the center of this? That looks like to be about the center to where our front axle is going to be. So it looks like we can go roughly 225 millimeters. And we still have plenty of room. We can go 250. And that's about 25. So we have about 75 more millimeters to play around with. Probably maybe more like 60. $200 millimeters. That's. I'm looking at the build plate of. What do I have that's 200 millimeters here? I have a piece of tape. So if I take this piece of tape and go from here, I'm trying to get an idea how big this thing's going to be. And if this is 150 millimeters from there to there, all we need is 50 millimeters. So that's 200 millimeters from there to there. Oh, this isn't going to be big at all. This is going to be a small little tiny thing. I don't have my overhead camera on, but let's see if I can. So from here to here to where my thumb's at, that's only 200 millimeters. And then this is basically going to be in the center of that. It's got a small little thing. right, so let's try this. How wide are we going on this? So from there to there. It's roughly 143. Digital Dragon, my friend, how are you doing today? We are working on an AI, it's going to be an AI-driven rover for Murph and to take out the shows, which is going to eventually be turned into a death racer. Somewhat. We got a couple ideas of what to do for a death racer. We might do a collab. But this is going to send us down the path of a death racer. Living the dream, huh? Right now, I'm just trying to get ideas of how big this machine that it's going to be a tracked, it's going to be tracked. But I'm just now getting an idea of a rough idea. I'm laying tape down on my desk to kind of simulate how big this thing's going to be. And it's kind of small. But it's going to have LiDAR, 360 LiDAR. We're running steppers for the motor drivers, and then we're going to have a robotic arm on it. We're just doing shenanigans, I guess. We're using these. These are the motor. Our motors that we're using. There's a lot of parts we're using. The motors are the motors off of that Core XY from the belt, the additive 3D. Yeah, we're using those because to be honest with you, I don't think I'm going to finish out that project. after watching you and you not being happy with it, I started thinking about it. It's like, yeah, I don't know about this. So we're gonna basically strip that that Core XY kit, strip it, use the components for this build, plus a couple other builds too. I can use it for the CNC, and yeah, that's what we're gonna end up doing. It's all put together. All it needs is wired. That's all it needs is the wiring done to it. I caught that in your stream the other day. Yeah, I know. I heard that when I was in your stream, lurking in your stream the other day. A rideable death racer. So this is our machine right now. And this is a 300 millimeter build plate. So when I do these, I like to do an outline of the build plate so we can have an idea. Cause I want to print this all in one, right? I want the body to be printed as one. I don't want to sit there and have to worry about weak points assembling it. Yeah, that'd be pretty sweet to have a rideable death racer. Yeah, I just need to wire mine up is all I really need to do. I mean, the only thing I'm really using for this build is the two steppers. That's all I'm really using out of it, and then. Yeah, I have another project for a coil winder that's going to use another stepper. The two steppers are on there, But the steppers that are on there now are for when I was trying to do the 5-axis. So those are steppers from the original one. So I don't use, they were just added on by me. I got a bunch of steppers laying around. But basically what I'm trying to do is I got way too much stuff. I have way too much stuff that's just sitting around doing nothing. Like I got boards all over the place. I mean, I got a bunch of boards. I got steppers. I got drivers. I got all kinds of stuff. Bearings, axles, all kinds of electronic things like that, just in all these boxes here. So I'm slowly going through everything and designing projects around the stuff that I already have. So I'm not out buying more stuff. I can make do the projects, with my existing stuff, designing my using my ideas, designing around the stuff that I already have. So they're not sitting around collecting dust or, it's taking up space. We can actually make something out of it. Because a lot of the times when I make these projects and I start working on these projects, I come across where, I'll need a certain component. And I've fallen over some stuff, but I haven't broken my toes yet. So you got one up on me on that one. How are you feeling? Is that healing on you? Is that you feeling better over that? Yeah, as I was saying, a lot of my projects I'll start. Well, the Core XY. The reason why I stopped that project is because I didn't have I wanted some of the red ASA, the Galaxy Red ASA, which I got, and I actually got another roll in the other day. So I have a roll and a half. I was printing with that because we do have a project right here that needs to be put together, but I need to order some bearings and stuff for it. So this one here, this is that Red Galaxy, or Galaxy Red ASA from Polymaker. This project is all fully printed now. I have about 90% of the parts, the electronics. This is a coil winding machine. So that is going to be used. We need to get that together so we can wind our coils. This is getting redesigned. This is our brushless motor. This is getting redesigned where these stators come out, and then we'll be able to put them on the machine, and we'll be able to CNC wind them. And that's what this is. This is a CNC winding machine, and then we'll be able to wind it. And then once it's wound, we'll be able to put it on here and attach it. So then we can get that going. We can get our brushless motor up and running. It's been throbbing today for some reason. So yeah, that's my new goals now, is to work around for the stuff I currently have, so I don't have to buy new stuff. Now this robotic tank destroyer thing that we're making right now, we are going to get I'm leaning towards Raspberry Pi. The new ones, I already have Raspberry Pis, but I'm leaning towards the Raspberry Pi 5 with the AI camera on it. So for avoidance detection and stuff like that. We are going to be running 360-degree LiDAR around it. I found a LiDAR system that rotates, and that will be placed up on top of this as well. Which actually I want to see what the size of that is, if it will fit into our current build. I think we might have to make this thing a little bit wider than longer. So we'll go to, what was it? I found it on Amazon. But yeah, that's the goal, is to start making stuff off of all my existing electronics. So this is the LiDAR I want to use. Let's go to the big screen here. So the LiDAR is going to be used for, so we can get a 360-degree view so the computer will know. It's not going to show, but this is what I'm going to use. I want to see what the specs of this is. Specifications. I'm trying to see how big it is. So this measures 4,000 points per second. Not telling me how. I want to know what the size of it is. Product dimensions. Okay, so we'll say 4, we'll say 2.5 by 1.5. So that's 4 inches by 2.5. What's 4 inches to millimeters? That's our biggest. So it's 101. It's 101 millimeters. What is our model? That would be placed about back in here. What did I say, 101? Now that's rounded up. So that would definitely fit within our model. What's 2.5 inches? It's 63, and obviously that was 70. So we definitely, so if we go $104, $102, and the object you're creating is not visible. So that blue, we definitely have space there. This obviously will be up in the air, like it'll be up, but that will definitely fit within our structure, our body. Cool. Okay, so that will work. All right. Let's get back. Oh, I was in an ad. I don't have my Twitch turned on to see what's going on. It's not accurate half the time anyway. So yeah, this little blue square here, this blue square is rounded up of the size of the LiDAR. So the LiDAR will fit in that place, which means it will fit within the body. I guess now it just, oh, we need to do the batteries. That's what it is. Finish this sketch here. We turn that sketch off. We need to finish the batteries. The batteries, we will work off of this. The batteries are going to be up front. Now, the batteries are going to determine this length of this, basically. Where's my calipers at? So our batteries are, I don't know who you are. Stop calling me. volume off. That's how you handle that. Okay, so our batteries with the tucking of the wire, we're looking at about 120. $120 by what? $120 by 35, and I'm going to leave about 6 millimeters on each side. For wiring. That would give us 12 millimeters, so that would be okay. Why did I do that? From point to point. So that's what, 120 by 27? Is that already in 35? We're going to mirror this. Why can't we select our mirror line? Well, we'll just have to make one. All right, so how thick is our battery? Our battery thicknesses are going to be, I'm going to say 30, just to be on the safe side. Yes, we are going to be, we are going to be running some ducting in through here. There is going to be a channel. I haven't done it, I didn't mod it up or model it yet, but there's going to be a channel through here the whole way around it. And then there's going to be a fan probably up front here somewhere, but there will be a fan that there's going to be 2 fans, one for each stepper, that's going to be able to, it's going to take fresh air the whole way around the motor. And then we'll have a fan in the back here that blows over all this here. So yep. Let's do, oh, we need the body. What did I say, 30? Symmetrical 30, so we'll do 15. So that's the battery. We're running 2 of these batteries, and these are 2200 milliamp hour batteries, 35C. And yeah, these are a 3S. So we're going to be running 2 of these. And we should, with a 35C, we'll have plenty of discharge power to run through here. This is going to be modular, right? So the idea of this is to build a platform to where we have the front of it. The front of it is going to be a flat plate, and you'll be able to swap things out, swap out different things. Right now, we're trying to get our main components. I'm not worried about the back. There's going to be a Raspberry Pi, an Arduino. We have the Pi hat, and then we have the H bridge for the steppers and the motors. So that's definitely going to be stacked. And then we have the LiDAR system that's going to be in the back here somewhere. And then we have a front-facing camera that's going to be here. We're going to have two... well, you know what? I bet you I could run just the one camera for our main camera. We'll get to that point when that point comes. This battery needs to be moved forward because it's going to interfere with those right there. So we definitely need to move this battery forward. We can actually move the batteries out because there's still lots of room in here. So let's move the battery. Move the battery 20 millimeters off to the side. And okay. And let's move this body. Gorgeki Designs, welcome in, my friend. How are you doing today? Did you get your bears all back up and running? Did they destroy it? How's everything with you? We are working on our robotic tank grabber arm thing. Basically, okay, I guess the best way to describe what we're making is a one of those explosive removal bots. I guess that would be the best way to describe that. So that's I absolutely do that. No, people need to stop calling me. I swear to God. "3D Printer Shack," how are you doing, my friend? So this Gicky Jack, hey, how are you doing? So this is basically what we're making. I'm trying to find one that's close to. Look at this crazy thing with like arms and stuff. Just got home from picking up kids from school. Yeah, my son's gonna be home here pretty soon. Okay, so this is somewhat close to it. Not completely. It's more. It's basically gonna be something like this guy right here, with the arm in the front. So, but trying to find one that has my back again, and welcome back. Trying to find one that has my like what I'm envisioning. Something like this. Something like that, right? Close to it. That's picking up a duck. But this part here is gonna sit lower. It's gonna sit down here. It's not gonna be up so high. It's gonna fold up. And then we're gonna have our hump up here. There's gonna be a hump up here that has the sensors. The LiDAR is gonna be up on top here, spinning around. We'll have our camera up here. We'll probably have a camera. We'll probably have an FPV camera up here, and maybe one down here. But there's going to be the AI camera is going to be down here, most likely. But the way that is the way I want my arm to be. Yeah, no, kind of like how that is. But all of our motors, electronic, all that stuff's gonna be in the back here, and then it's gonna fold up like that. That's my vision. Look, on Amazon we can get this for $50, really. Oh, it uses servos. Nope, don't want to use servos. It's not a bad price, though. We got to move these batteries down. And this is going to be an off-road, so the tracks are going to be nice and wide. Running Boom Bear 24/7 is your PC. Well, when I ran that was an 18-hour long stream of Boom Bears, I was here. Oh yeah, you also have your printer cams and stuff too. When I was just running the game itself, I had Lumia Stream shut down. I had everything all shut down. Just my streaming, just OBS up and running in Boom Bears. I started that game, and I was still here at the house for 2 hours. I went and took a 2-hour nap before I went to work. So you guys were playing that game while I was still here, and I kept it. I knew people were playing it because I kept hearing the ending, the winning chime that it was doing. But I could hear my PC was No, I have my fans set to variable, so they adjust with temperature. They adjust. Well, my case adjusts with temperature, but my PC, my CPU fan goes up during processes. But yeah, I kept hearing it go like going up and down, up and down, up and down. So it does take resources, huh? Yeah, I completely derailed myself. I understand I derailed myself on that one. I started thinking about this. I was like, oh, what can we do here? Okay, let's make this in line with the bottom here. That was 17.8. So remember that. We need to get back 17.8. Yeah, we could. So that's what, 17.8. We gotta go back. I did not measure. I did not know how far we went down on this. Yeah, well, you're running an i5. A GTX 1060. They're getting ready to release the, or maybe they have already, the 500 series or 5000 series. I guess they're not. I guess they're not as cooped up as they want them to be. So they're having problems with them or something. I don't know. All right, so there's our batteries. Especially with our batteries being like that, we can actually move them back now, can't we? So let's move them back. Because they're out of the way. Don't want them too close to that, but they're out of the way because we're going to have fans somewhere. I guess I can pull the fans here, and then I can bring that down, up and around. Yeah. So that's 13 millimeters. I better take that up a little bit. So we'll do 10. Yeah, that will work. Yeah, because I can cut this out here. This here is basically for support. So we can actually put a fan on this right here, and then have this hollowed out, and pull air in and exhaust it after that way. So that's something we can definitely do. Move this back 10. So let's move this back 10. That will give us room for any other electronics that we might need to be put in here. Yeah, I saw the prices on there. Definitely way overpriced. I thought the 4000 series were overpriced myself, but those 500s or those 5000s, yeah, my God. Oh, I think I just happened to look over on my other screen here. This is basically what we're doing right here. That's what we're doing. Oh, it's got LiDAR on it too. But we are going to be running the ROS. We are running, yeah, this is basically what we're making. This is like the whole kit for $1,000. Holy God! But that's what we're that's what we're making. The tanks, the tracks are a little bit different, but that's basically what we're gonna make. We're making like a low profile version of it. But you see how that front see how the front arm is. We're going to be using servos. Or not servos, we're going to be using steppers, or little small NEMA 14s, but that's going to be an interesting build. But that is what we're making. Their design products are killing. Yeah, that was kind of crazy, wasn't it? Design products are killing your MacBook, huh? I ran a MacBook for a while, but I no longer do. That MacBook was great for editing photos and videos. Yeah, my time's coming up too. My son's gonna be home soon. All right, so let's do. This is what we're gonna close this. We're gonna delete that. Let's bring in our Raspberry Pi. .3D Print World, have a great rest of your day. Thank you for stopping in, my friend, and hope to see you soon. I wish there was better lighting on here. So that needs to come up. Actually, no, we can run that down here. And we'll have definitely one stack on here for the camera system. We might have an extension board on here too. We can run. Oh, where are we going to put our? Where are we going to put our controller? That is not going to fit in with our batteries. The only way that will fit with our batteries is if we turn our batteries. Well, we can bring our batteries out even more. So we can bring our batteries out to here because this is where the outside wall is going to be. So we do still have room. So what if we... That's at 90. Okay, we're okay on that. And let's move our batteries out even more. Ramon, how you doing, my friend? Hi, Bushmaster. Welcome in. Yeah, I'm on for, well, no, I'm not on for another 30 minutes. I'm on for about another 10, 15 minutes. I usually try to end it by 3 o'clock. Oh, really? Does it? I looked at orange pies, but the ones I've been finding with orange pies are very expensive. Oh, darn it. Undo that. So that's, we can also move the battery this way. That will give us room. We'll take it up to there. And we can bring it out, say out to here. Let me have some cushioning. So that's 10-4. Mic bit low? I don't know if it might be. Yeah, but there's the orange pies. So I have no problem with going with an orange pie. Is that battery? Yeah, that battery's up, but that's okay. I've never played around with the orange pie before. I'd kind of like to try it. 10-4. So, okay. So this is our Arduino. We'd want to rotate this. So I have access to these if needed. The AI module, yeah, no, I noticed that it's available as a USB. Oh, did they? They dropped all the video. Huh. Now, are we still within our box? Nope. Nope, we're not. Well, technically we are. So we have a front axle to worry about up here. We could raise the batteries. Oh yeah, because that would definitely with Octopi. Oh my god, yeah, I didn't even think of that. All right, so our front axle is going to be, we better make our front axle. So that's where our front axle is going to be. Oh, you know what? No, it's not, because our bearings are 22. Our bearings are 22.25. That's our bearings. Which still is barely in there. It definitely needs to be moved back a little bit. We do have a little bit of room back here. How much do we have back here? This is... Alright, so we can come back like 10 millimeters. I want this body to print as one piece. So if we come back 10 millimeters. Okay, now we're good on that. We're good. Can we run that AI on the 3B? Because I have one sitting right here in front of me. Now this is a 3B. It's a 3B plus or 3B something. Raspberry Pi 3B plus. No, this is just 3B version 1.2. It's not a plus. I think we have everything. I think we have everything all mapped out. What if there's a model of that on... oh crap, I closed out my thing. On GrabCAD, but what if there's a model of that LiDAR on there? There are models on here. Oh, is that it? That looks like it. Please have an STL. You do. The 400 will be okay for all that. Import. We might have to do some removal of components. And I don't, probably something like that. That stays within. Our tank will come up here. These supports, we can shrink these supports down. I don't think this LiDAR is directional as far as I don't think it needs to be a certain way. I think we can do all that in coding. So I think we have all of our components. The only thing we don't have in here is we're going to have the Pi, or the Pi hat, or the AI hat was going to go in here. Our cameras, but we can figure out the cameras later. And then we're going to have our Arduino here with a H bridge. We might have to do a dual stack of the H bridge though, because we're going to have what, 6 servos or 6 steppers. We can do an H bridge that has 4, and I think we can double stack the four stepper. I think we can double stack that one. It will give us a total of 8, so we'll have 2 channels left over, or 2 stepper channels left over. What can we do with those? As a what? As a pie hole for a while before we did the server. So we are going to be, let's finish that sketch. I'm going to be adding, well, for the tires, you know what we should probably do? Let's go to this. We'll say they're about right there. 80. This I'm going to be removing. This is just to give me an idea. So that's basically going to be our sprocket. Maybe not that thick. Definitely not that thick. But that's going to be our sprocket. Let's move this back down. I just realized something. Yeah, I just realized something. So this is how I want the track to go. But I wanted to try to keep this all nice and even down here. But I want the track to come out. I guess we can do it right here. I guess I could probably make it. You know what? Text you, I was thinking about making one of those. I was watching instructions on how to do that while listening to it today while I was driving down the road. Let's do an offset. So something like that. And we'll run just some carriage pulleys up here, and we'll run a pulley here. This will be an idler pulley. This will be an idler pulley. We can just A-frame that. Yeah, we can run an internal structure here and then have that internal structure attached to the body. I realized something. We don't have a way. We put screws into here. How are we going to screw that with the battery there? We can run a screw right through here and into there, so we can have two here. We will have probably about 10 millimeter thickness down here. No, so this isn't the base of it. We'll still have a shield down the bottom. So I guess we can run a shield through there. Exactly, screwed in the battery. What can go wrong? I mean, you all want fire, right? So that still keeps it on the build plate. So yeah. We can also, with the body here, we didn't even think, I just now realized, I just saw that when we print the body out, we can have the body in, we can have inserts coming out of the body. So this unit here goes onto the body, and then we can screw into those tabs. So that will work. But this is going to be an interesting project. Definitely going to be an interesting project. And then this whole section here is modular. We can make these modular for other motors, but I think this will work. I think we're good to go. I think we're good to start designing the body of it and start printing the body out. Where's the fire? Well, this part here is going to be modular. This here is going to be, you'll be able to pop a different plate in. So if you want to put a flamethrower, you can put a flamethrower on it. We'll do a flamethrower for it. We can't take that to any kind of events. We'll probably get kicked out. Probably. So let's do, get rid of the sketches. Let's go into, let's do render of this real quick. I saved it. Oh yeah, BB shooter module. Yeah. Why is the design being saved? I'm not understanding why it's... I'm not understanding what's going on here. Oh, because I'm offline, that's why. I know. he wants to prevent it, huh? Render this. We'll download this. I already know where we're gonna go. Save that in pictures. I won't even touch it up. We'll just keep it how it is. Close that out. Make it into. Get into my regular screen here. Go to chat. Let's get that done and out with. I need to go into Discord. Where's my Cruising Grill? Where's my ads at? We cancel them if you can, please. How you doing, my friend? We are just getting ready to raid out here. Do I have? I'll show you what we were working on, but my son is going to be home like any second now. And I don't see where my picture was saved at. How are you doing today, my friend? Okay, I don't know where that picture's at. Anyway, so this is what we got here. Oh, you're not seeing it at all. That's what we got. This is what we were working on today. We are prototyping a tracked machine that's going to be autonomous. We're using AI and all that stuff, and it's going to have a robot arm in the front of it. So it's going to be basically like just a tank with a robot arm, like one of those bomb disposable robots, right? This is a 360 lidar. So it's going to have we're going to run lidar on it, and yeah, we basically have all the components already. All we really need is the lidar, and I need to get some, possibly, I think the Orange Pi or Raspberry Pi. I don't know what we're going to get for that board yet. But we are going to be using the AI the AI camera for it. A Lego Monster control on it. Oh, download it as. Oh, that's why. So we can't download it as a PNG. I should still. Oh, there it is. Okay, got it. I'm trolling somebody. I'm trolling somebody. Anyway, all right, I gotta go. I seriously have to go. My son's like, I'm surprised he's not knocking at the door yet. What the heck? Get back to my dashboard. Raid. We're gonna head off to the Free Heathen. He understands that I gotta go. It's been a while since I raided into him, but for some reason I can't pull him up. He was just right there. Right there he is. There, we're gonna start the raid. Everybody, thank you all for stopping in. This is gonna be an interesting project. There's gonna be a lot of learning I need to do with this. Digital Dragon, my friend, hope you're feeling better. How about the John? I hope you make it home safe. Safe travels, my friend. Everybody, thank you all for stopping in. We're off to the Free Heathen. I seriously got to go. The button is purple. See ya.